Let's look at a way that we can use our calculator to help us pass the Algebra 1 SOL. So here's a released SOL, and let's look at some of the problems. Let's first start with the sample. So when we look here, we see an equal sign right here. Okay, so when we see an equal sign, that means we want this side to be the same as this side. So in our calculator, we're going to put the left side in y1 and the y side in y2. So I'm looking for where my y's will be the same. So what value of x makes both of these the same? So when I do that, I'm going to be looking for what's called the intersection. So I'm going to go 3 times 2x minus 1, close my parentheses, and on the next line I'm going to write 3. So there's 2 ways I can do this. I can look at the graph. I didn't change my graph. I need to change my graph. I forgot to clear that. What I'm talking about is you can see how tight these railroad tracks are together. So for the sake of what we're going to do right now, I'm just going to put that back so you can see how the railroad tracks are wider apart. So this was my y1 that just drew in, and this is my y2 that just drew in. So if I'm going to sketch this, my y1 is like this, and my y2 is like this. y2, y1. What I'm looking for is this intersection right here. So the intersection right there is the same point, which means my x and my y will have the same values. So I'm going to do second, and then I'm going to do trace. So let's write that down, because this is when we have equals, this happens a lot. I'm going to do second, and then I'm going to do trace. Then I'm looking for the intersection, number 5. Intersect. So let's go to number 5. So there's my cursor. It says first curve. It's showing me the equation. It's on the blue one. I can leave it there, or I can move it closer, and then I'm going to push enter, and notice this is second curve. It changed. It's now on my red line, y2. It's good enough. That's close. It's good enough. Notice how it says intersection. So this point here is at the point 1, 3. I'm only concerned about my x value. So this is where x equals 1. So my solution is C. Let's look at another problem. So this is a little different. This is not an equation. So I just want to know the value of this function when x is 4. So again, there's more than one way I can do this. I'm going to show you one method. So I could put this in my y equals. So let's go back to my y equals. I'm going to clear it. I'm going to clear it. And then here I'm going to put in a fraction. Now students get confused when they put in a fraction. In our TI-84, we have the ability to make a fraction that looks like this. So let's do, it's alpha, and that F1 is green, which is what we want. So we can see this is different ways our numbers can show. So the first one is our fraction. So you can see it made it look like a fraction. So I'm going to put 3 in my numerator and x plus 2 in my denominator. Okay? So here I'm going to enter that into y1 equals. Then I'm going to go to my table. So my table is right here. It's in blue. So I'm going to do second graph. Okay, that's the button I would push. And that's going to give me my table. So second graph. So we can see here in our table we have different values of x. Well, what do I want x? I'm going to look for x is 4 in the table. So where is x4? Well, here it's 0, 1, 2, 3, 4. So when x is 4, I get an answer of 1/2. So that means right here, my answer is 1/2. Okay, so that's one way of doing it. I'm going to show you a second way to do it. So the second way to do it is I want to figure out what the value is when x equals 4. So you could just substitute that in, but sometimes it gets crazy. This is a simple problem. So what I want to do is I want to take the number 4 and I want to store it into my variable x. So I'm going to go to my regular screen, and I do that by doing second quit. It got me out of that other screen. I'm going to push 4, and if you notice this button right here, STO, that's store, and I'm going to put in x, and I'm going to put in enter. So now whenever I use the value of x, my calculator believes it to be 4. So now I'm just going to put this right on the calculator screen. So my regular screen, I'm going to again do alpha F1, I'm going to get that little fraction, and I'm going to put 3 in the numerator, and I'm going to put x plus 2 in the denominator, and then I'm going to push enter, and there we go, we get 1/2. So that was 2 different ways to do the same problem. So those were both my samples. Let's look at another one. This is problem number 1. So it's asking us to look at the graph function shown. So I find often a lot of students don't know what is meant by the graphed function. Well, this is my graphed function right through here. So that's my function that's graphed. And it has some key words that we're looking for. So it's saying based on the zeros. So this is a vocabulary word. So zeros is actually a nickname. So this here is a nickname for x-intercepts. Okay, so my x-intercepts are wherever my graph crosses my x-axis. So I have an x-intercept here, and I have an x-intercept here. Okay, so based on the zeros, which represents the graph function. The key word here is best. It may not be exact. So what are we looking for? We're looking for a function that has zeros where? Well, right here, x has the value 1, so I'm looking for where x has the value 1, and here I'm looking for where x has the value 3. If we were going to write that as a point, that means my graph has to have the point 1, 0 and 3, 0. So the reason we call things zeros is because that's where our y is 0. Okay? So what we're going to do, I don't know the equation to this, but I can see which one of these is going to cross my x-intercept at either 1, 0 and 3, 0. So this is all one function, so I'm going to put this in my calculator as all one function, just as I see it. Parentheses x minus 3, and then 2x plus 2. I'm going to go ahead and graph it. I'm going to look to see if it crosses. Well, it doesn't. Okay, so this one crosses at where x is -1 and where x is 3. So that can't be it. So now I'm going to move on to the next one. Let's clear that. So let's put in the next one. 2x plus 6 and then x plus 1. Let's graph that. Does it share the same zeros? Well, clearly not. Okay, let's go on to the next one. 2x plus 3, x minus 1. Let's graph it. Okay, that one has a 1, but it doesn't have the 3. So hopefully, unless I misunderstood the question, this should be our answer. X minus 3, X minus 1, and that should cross. See, we can see right there our x-intercept. We have an x-intercept at x is 1 and an x-intercept at x is 3. So that means that this is our answer for that one.